Well, hello everyone, and today we'll be seeing one of the problem from lead code. The problem says flip equivalent binary trees. Now, let's say what the flip operation is. Let's see that if we have a binary tree T and we can define a flip operation in a way that we choose any node and swap its left and right subtrees. Now, a binary tree X is flipped equivalent to a binary tree Y if and only if we can make X equal to Y after some number of flip operations. Now, you see here they have made a flip operation as 2 and 3 are flipped, but you see for 2 they have not made any flip operations because left of 2 is 4, and here as well you can see left of 2 is 4. So, it is may or may not kind of situation. So, now here it is said that we are given two roots of a binary trees. It is root 1 and root 2, and we need to return true if these true are trees are flip equivalent or else false. Now as you can see it is flipped, but still it is a flip operation, we are allowing it. 2 5, yeah, sorry, 4 5, 4 5 we see, with 3 we see 6, with 5 we see 7 and 8, with 5 we see 8 and 7 which is flipped. We can understand that. So the funda is pretty simple within this, and hence we say it is a true. Now we come below that we see, hey, both of the tree are null. Now within this situation as well it returns true. Okay, understandable, because this is empty, this is empty, so empty flipped or unflipped it is still the same, and hence it is true. Interesting things lies where we find out that, hey, if one is empty, one is not empty, either of them is empty, then it's false. You see, these questions are very interesting because they open up a very new perspective. Whether you go around, think of the test cases, what it might be, what are the permutation combinations which might happen, and hence you make your own solution to it. So we'll be going in a similar manner and checking that how we can deal with this problem. We'll see one by one test cases. Like, as of now, from these examples we came to know that, hey, if both of them are null, so if I say root 1 and root 2 are null, then it's valid. Valid means it's a true flip equivalent. And if I'll say that, hey, if root 1 or root 2 either of them are null, then it's not false, because either of them is null and one is not null, then that would give rise to not a flip equivalent. It is also interesting to know that, hey, 1 and 1 it has both the same data, so I can say that root 1 value of root 1 needs exactly be equal to value of root 2, then only we can say it as true, else we cannot. If it is not equal, let's say for reason, so we can just return false. So there are two things. See, here you flipped it and sometimes you don't flip it. So within 2 3 you flipped it, but within 4 5 you don't flipped it. So we need to check those condition as well, whether we flipped it or don't flipped it. Within 1 2 3 4 5, within these 5 steps we are done with our answer. So let's code this. So this is nothing but this statement which I can convert. Just let me spare me some time. Yeah, so what I'll do here is just go ahead. Okay, I'll just go ahead and say that this is an if statement and I want these two things, and this is nothing but a return statement. I'll just comment out these things as well. If you're wondering, the shortcut is Command D or Control D if you're using Mac or Windows correspondingly. So if this is null and root 2 is also equal to null, then return true. If this is equal to null or this is equal to null, then return false. Easy peasy. If this is not equal to this, then return false. If it is flipped, how do we know it is flipped? We check by using the same existing value, flip equivalent method. So I'll go ahead and check if it is flip equivalent to its childs as well, like I'm guessing like root 1 dot left with root 2 dot right. Why left and right? Because it's flipped, obviously. Also, not only I wanted to check left but also right of root 1. So I'll just say flip equivalent of root 1 dot right and root 2 dot left. Now we have covered both of the test cases, and if it does take place, we return true right from here. And same goes over here, but the only catch this time it is that it is not flipped. So we are comparing left with left and right with right. Ultimately, if nothing happens, then we return false. Yeah, let's compile this. For sample test cases, we are getting bunch of compiler errors and I'm liking it, and we are missing few semicolons. So here's one, second, third, and now let's run this. Okay, it's accepted for sample test cases. Let's check it for rest of the test cases, and yeah, we see our solution has been accepted. Do let me know what is the time complexity and space complexity for such an algorithm, and I'll see you in the next one.